Welcome to my talk, and thank you for coming here today. I'm really excited to present in this conference. So, let's start with something that we are all familiar with. Imagine Friday evening after a long and busy week. You want to indulge yourself in a couple of beers, glass of wine, and to watch something on the TV. You turn on your favorite streaming service, and then you start searching. Comedies, dramas, critically acclaimed TV shows, movie that everyone is talking about, but you're still searching and searching. You can't find what you want to watch. After couple of half an hour or something like that, you just the thing that you found is just your own frustration and anxiety. In the end, you turn off the TV or you watch a sitcom that you watched 10 years ago. That is called a paradox of choice. It is scientifically proven that more choices leads to more anxiety, more frustration, that leads to indecision or no decision at all. But how we can move away from it? It's simple, relatively simple. You just need two things. The first is a great product catalog with a lot of description, a lot of metadata that you can use to create something that you can search for. Then, if you want even better results, then you need customer engagement data that you can personalize and further improve your search results that you're showing to the customers. In the end, you end up with turning frustrated searches to the potential sales. You understand your customers better, and you provide to them what they want. How we can move away from the traditional search, and how we can go beyond that and improve on that. To understand that, let's first see the search bar and how the traditional search work. You type some query, and then behind the scenes, system tries to match words with the words from the product description. It is called a keyword search. And it is a language. It is not that exact. And you end up lost in translation. It is not literate. And for example, in this example, you can see the warm top for winter could mean either winter tires, could mean either boots, or could mean sweaters. But it doesn't understand the meaning and the intent behind the query. Semantic search, on the other hand, tries to handle exactly that. It tries to match query and the product by meaning. And then you end up, when asking for warm top for winter, it is probably the thing that you want is a sweater. And with the semantic search, what you could end up with applying more complex queries, such as eco-friendly coffee machine with no pods. Even though these words aren't mentioned inside the product description per se, it means that semantic search will try to find, based on the description and the meaning, what you actually want. And how does this work? In the nutshell, the most important thing in the semantic search is a vector. What is a vector or embedding? It's a numerical representation that carries the meaning of the product itself. If you have a product catalog, then you pass the product, title, descriptions, any other metadata to the encoder model that transforms the text of that into the vector, a compressed representation that carries the meaning. And then you store these vectors to the specialized database that can be indexed and searched easily. Now, when you have the query, the same process. You take the query text, you pass it to the same encoder model, it transforms it to the vector that carries the intent and meaning of the query. That vector you pass to the database, vector database, and then it returns the top products matched by similarity, matched by the meaning. This allows us, if someone asks for cozy sweater, to be matched with a warm top for winter, for example. How we can improve that, and what is something that is tied to the results? You can argue that one of the things that contributes to the search results is embedding or vector itself. The better embeddings, the better search results. And with lately LLMs and VLMs, we can crunch a lot of data regarding the products. We are not tied just to the description, because descriptions of the products are usually written by the users, and it carries a lot of junk. It carries some noisy text that users just add to be at the top of the search. But using LLMs, you can pass that description, you can pass the image of the product, for example, and ask for that description. You can also pass the reviews and see if there is any important information. For example, one hiking book could be specialized for the snow, and it is confirmed by the users in the reviews. This is all useful data that you can extract and enrich your product catalog, so once you transform it to the embedding, you will get the better results. Will that solve all our problems? No, it is not a silver bullet. In the end, it mostly depends on the query types that your users are writing. It could be a single word queries or something specific like iPhone 16. Then semantic search, you won't get any benefit from the semantic search there. But on the other side, if the queries are more exploratory in nature, such as outfits for the fall, then semantic search will translate this vague use query and connect with the other products in your catalog. There are many query types that you can classify at the beginning of the search process, so you can reroute to the best part of the system that could handle the queries. Such query types are complementary queries. You have something, but you want something that complements that product. For example, you have a red dress and you want to find shoes that are matching to the red dress. Another type of the queries could be inspirational. You can type, I want to look like James Bond. And then system should be able to recognize what you're looking for and then present you the best outfit there. Or something like eco-friendly coffee machine that you want to solve some problems with it. Another thing that you can possibly add to your query understanding module is that you can dissect the query and understand what is the meaning behind these words. So you can find the user might want asking for a brand, color, gender, size, or some occasion like beach wedding. And then you can use all this information to further use filters or boosting for the search results and to improve it. Where you can put that? Well, basically, if you have the small LLM, or you can train your own named entity recognition as a query understanding module, we usually put that after the query. So you get the query, you pass it to the train query understanding module, and with the information from there, you can reroute it to the different part of the system that can handle that type of the query. Now, we understand our users, what they want by using query understanding, and then we can search product by using either keyword search, semantic search, hybrid, or whatever we want. But at the end, it will always show the same results. And I think it is a waste. The next thing that lies at the top of the search is called reranking. And that reranking could just it will take the search results and then it will sort them out. And the good thing is that you can fine-tune it, so you can either include personalization, or you just want to optimize for the relevancy, for the clicks, for the conversions, or whatever metric that you want to optimize for. Now, the question is, why are we using semantic search and not just use reranker on the whole product catalog once we get the query? The answer is that with the re-rankers, they're usually slow. And then that means that if you have the query and if you want to re-rank query against the whole product catalog, it will take hours. So there is a compromise. The compromise is multi-stage retrieval, where we have the first stage, something that we already talked about. It is semantic search. We got the query, we pass it to the bi-encoder, and then with the vector, we perform the semantic search. Semantic search returns the results ranked by similarity score, and then we can take a portion of that and pass it to the re-ranker that can further optimize for the objective. That objective could be optimize for clicks, optimize for conversions. And this is something that you can fine-tune to improve the search results. You can rank them so that the top results, top elements, top products to be shown to the customers are the most relevant one to that customer. We already discussed that we can improve the search by improving embeddings, right? There are, let's say, two more options. You can adapt embeddings to your domain, to your data. And what I mean by that we can fine-tune the bi-encoder. If you have the client's engagement data, or you just want to better align it to your terminology, then we can fine-tune the bi-encoder. After that, we can optimize for some business metrics, or just add customer preferences. Then we can use the re-ranker to further improve search. For the training bi-encoders, we want to train embeddings. So how we can do that? We need usually triplets. Query, some product that user has clicked, let's say, we want to optimize for the clicks, and the other products that user didn't click in the same search session. And if we have enough examples, we can fine-tune the bi-encoder, which is transformer in nature. And we want to have to pull embeddings of the query and the positive product closer and push away the negative one. And after many iterations, we can adapt embedding model bi-encoder to our data. After that, we want to optimize reranker. Something similar we want with the data. We need positives, negatives, either we want to optimize for the clicks, or we want to optimize for the sales, or we want to fuse something. Even though we need labels, we need engagement data. Once we have that, we can use learning to rank framework that will take some product features, user features if we want to personalize, some engagement that are tied between user and the similar products, and also the query. We can pass that to the either XGBoost if you want to optimize for the speed and for really good accuracy, or we can opt for the cross-encoder if the features are more text related. After training, we can just plug the reranker to perform after the semantic search part. Okay, this is a foundational of any modern search engine. First, we understood the customers, what they want. Based on that, we can pass that to the different subsystem that performs a search, either keyword or semantic. And at the top of that, we build a personalization layer. Now, with that foundation, we have seen a couple of products that already have a conversational part. We are wired to the keyword search. We use it in the Google for 20 years or so. But the younger generation are growing up with the ChatGPT. They are growing up with the conversational part. And we can prepare for that. And we already seen like Amazon or any other product that have implemented conversational part that could help you find the products that you want. For example, you're going to trip to Hawaii, and then you just read that. Usually the search engines would give you some books or something like that, but the conversational part will understand that you probably need some beach equipment, and then it will pass you as a search results. Or in this case, I just need a gym outfit. And the agent figured out that for the gym outfit, I usually need shirt, shorts, shoes, socks. And then if he already has the my preferences, for example, the colors I like or the brands that I prefer, then he can add that personalization part to the search. After that, you can ask some questions regarding the product itself. For example, if training shoes can go outside or not. And then, again, the conversational layer would figure out which tool behind the scene to use. And this is something that it is probably that we are going right now to have all this foundation and then a conversational layer that could help the customers find what they want. So to recap, in this session we covered the foundational search, how we can move beyond the traditional one with the keyword. We understood the queries, and we understood the customers by building the query understanding module before. And then at the top of the search results, we can choose the right model to perform a personalization, and we can adapt all these models to our data. I would like to thank you for this talk, and if you have any questions, we can discuss it right now, or you can catch me here in the hallway. Thank you. Okay.
So, are you doing this encoding, KNN, reranking at query time, or is it like pre-computed? How do you usually?
Okay. The question is, if are we doing the encoding and reranking at the query time, or we are pre-computing it? We can first prepare all the data. I mean the product catalog. We can pre-compute it, get the vectors, embeddings for it, and then we store that into the vector database. At the query time, we usually need something that is less than 100 milliseconds. So we just transform the query. And also, if we have the query understanding module, we need to perform the classification part. If we don't, then we just transform the query to the embedding and perform approximate KNN on the vector database. Then it can return thousands, hundreds or so results. And these results need to be passed to the reranker part at the query time. And this is where is your trade-off. Rerankers are usually slow, and then it will add few 50 to 100 milliseconds to your response times. And this is something that you can trade off to either have a re-ranker and the better search results, or you just want speed and to return the similarity search.
But it still sounds like very low times. Do you use like small models, or like small but specialized models, or?
Usually bi-encoders are fast, depending on what you are using. And I think OpenAI text small embedding is around 50 milliseconds or something, depending on your location. But you can always deploy your own smaller model for that. Query understanding, if you are using small LLMs, that it takes the time to classify the query and to find all the parts that you want to classify. Or either you can train the named entity recognition, which is a lot of smaller model, and it runs fast. Okay.
As I showed at the beginning, same query can, like, for two different users, can mean totally different thing. And how do you deal with such a
situation? So the question is, the same query for the two different users could mean a totally different thing. So that is a great question, and the way to I can think of one of the way to handle that is if you already have the profile of these users, and if you have a re-ranker that already has the information about the past activities of the users, then it will try to derive knowledge from that. If you don't have that, then I don't think there is a way to have different results, except that location or something like that, language location or so. Okay?
Latching on to that, is it vectors then, or is it part of the prompt that is containing the personal data, person, or at least the preferences?
Mm-hmm. Okay, the question is how we get the personal data, right? I've seen some examples with constructing a person user summary by using the LLMs, and then you can pre-compute that and use it for further on in the recommendations and the personalization. But I haven't seen that yet in production. It is still in the POC phases. The approach of creating features out of user profiles is something that is preferred right now and works in the industry. So you create a feature vector for your user. For example, how many times he visits the site. Is it a weekend, or in the last week did he search for the same item, and what she ordered yesterday or something like that. And with this feature you build the profile for your user. Okay.
Is semantic search always a solution for like different kinds of use cases? Because I can see that when you have like structured data of numerical values, then with like combined with some like let's say description of a product, how do you decide to use semantic search or like use the like traditional way of querying the database with the values? Let's say for example price. Someone asks, I want something like cheaper than a certain value with some other features like I don't know, with a color and size and functionality. How do you decide to break this down to?
Thanks. That's a great question. So the question is how we can decide when to use a semantic search and when to use the more structural search. For example, if someone asks for the colors, sizes, price range, and so on. This is a tricky part, that you can add this information to the text of the product, but once you transform that to embeddings, it is a compression. In the end, it loses important information. It might lose the numbers and the structure of your data, and it will perform the search on similarity, and it will totally skip some requirements that you specified in the query. That is why it is one of the way is to have that query understanding module, that once someone types, I want navy Under Armour t-shirt for men, then you can tag navy as the color, Under Armour as a brand, L as a size, for men as a gender. And then with that information, you can, after the search, you can either filter out the results, or you can boost the products that contains all these filters to the top. This is one way. There is also knowledge graphs, where you can build the graphs of your products, and then you can find the entry point with a semantic search, and then from there you can filter out the products that are matched. So something in between. Yes?
So thank you for the presentation. user lands on the website, is it?
Yes.
What if the user starts from ChatGPT?
Mhm. So the question is, what happens when user starts from the ChatGPT? I know it is a way for the products that you can index them and use SEO and create some tags that can be parsed from the outside, from the robots like ChatGPT. And then ChatGPT will be then responsible to find that products. It might not be to your website. You're just ChatGPT will just take the results from there. The other thing is, if ChatGPT creates the query, then you can pass that query to the site and hope for the best. Is this okay? So if you ask ChatGPT for red training shoes, okay, then it will perform a search across the whole web, right? And to get your results from there, then your products needs to be optimized with the SEO, for the search engine optimization. It needs to contain some tags and so your products could be boosted to the ChatGPT. But this is the only way to affect the search on the ChatGPT. I think there is no other way. You need to build the SEO optimization. Okay. Well, thank you everything for this session.